Welcome to the Silica Exposure Training for the cut stone industry. This training covers the identification, evaluation, and control of silica exposures in cut stone and stone fabrication industries. The training was developed by Georgia Tech's Safety, Health, and Environmental Services Group with funding from the U.S. Department of Labor's Susan Harwood Training Grant Program. This is Lesson 5. Engineering controls for task-specific exposures. Reducing employee exposure to silica dust requires implementing several measures from what we, as safety and health professionals, call the hierarchy of controls. The most effective method to reduce exposures to silica dust would be to fully automate the process with robotics, which would eliminate employee exposure. Employers could also reduce employee exposure by only fabricating slabs of stone and engineered stone that have low to no silica content. This means the employer would need to review safety data sheets for products prior to marketing these types of countertops to the customer. In this lesson, we are going to focus on the next level of hierarchy of controls, engineering controls. For stone fabrication, the two main forms of engineering controls are wet methods and the use of ventilation. OSHA requires employers to investigate engineering controls whenever exposures potentially exceed OSHA action levels or permissible exposure limits for silica. Respiratory protection and other forms of PPE are not considered an engineering control and are considered the last line of defense to protect employees from silica. Investigating engineering controls is so important because, as we stated in Lesson 2, when we have conducted sampling for companies fabricating engineered stone, when no controls were in place, and when employees were cutting, polishing, or performing other types of fabrication dry, the exposures were 34 to 46 times the permissible exposure limit and ranged from 1,700 to 2,300 micrograms per cubic meter. First, let's talk about wet methods. The purpose of using wet methods is to control dust by applying water at the dust-generating site. This method for fabricators typically means purchasing tools that are fully integrated with a wet method configuration. Adequate dust capture by water is dependent on a variety of factors: particle size, velocity, spray nozzle size, and location, and environmental factors such as water hardness, humidity, and weather. Water flow rates are not applicable to all types of equipment, so make sure to consult the manufacturer's recommendations and assess whether there is visible spray from the operation of tools. Even with ample amounts of water, employees may be exposed to fine droplets of water that have silica dust particles in them. In this video, you can see the silica dust that has settled on the outside of the cartridge of the employee's respirator, even though he is using wet methods. After implementing a wet control method, such as shown in these videos where you can see the use of a water jet attachment to the CNC machine to cut slabs, each employer should check the operation site to determine if the control method adequately reduces exposure. To do this, the employer can watch for visible dust and conduct air sampling to quantify employee exposure to silica. The benefit of using a CNC machine to perform much of the cutting is that employees do not need to stand in the vicinity during fabrication. The second form of engineering controls used in stone fabrication are dust collection systems or ventilation systems. Employers must make sure that dust collection systems are appropriately designed for the tool being used and will be effective in capturing the dust generated from the tool task without introducing an additional safety hazard. Today, there are lots of options for fully integrated dust control ventilation systems that are commercially available on the market. If an older system is retrofitted with a shroud to provide dust collection, it is imperative that the system not also introduce a safety hazard. In this photo, employees at a shop attached a broom handle to an orbital saw and then attached a HEPA vacuum to remove the dust. Unfortunately, when they did this, they also removed the guard that would have protected the employees from getting cut. One major reason to invest in commercially available dust control systems is for the installation aspect of the countertop process. Using one complete system minimizes leaks, setup time, and training required for the employees that go out into the field to install the countertops. It also meets the requirements for construction-related installation on what we refer to as Table 1 of the Silica Standard for Construction Industry. These all-in-one systems also maximize efficiency of the vacuum system, and typically the vendor will be able to provide the company with data to back up the efficiency of the system. Finally, if the company has a fleet of trucks for the installation, these vehicles can be outfitted with the equipment for ease of installation. One factor to consider when grinding and polishing stone surfaces is that the sanding discs come in a wide variety of sizes, grits, and holes for dust control. The number of holes in the discs will vary based on if it is a water delivery system or a dust ventilation or vacuum system. You can see that all of these discs have one hole. This is because the company uses a specific type of water delivery system with one water source. If you are using a vacuum type system for a sander or polisher, the more holes, the better the dust capture. Just keep in mind, the higher the grit, the finer the abrasive. The finer the dust may be getting into the air. Our recommendation is that all employers, even if they are using wet methods, ventilation, or both wet methods and ventilation, should perform air sampling to determine the true employee exposure to silica when fabricating engineered stone countertops. With the silica content being so high for engineered stone countertops, and since the quartz used to create the countertops was already crushed once, meaning the quartz breaks into even finer particles when employees grind, polish, or cut the stone, the potential for employees to be exposed to silica above the action level or permissible exposure limit is much greater. As we stated during an earlier lesson, the data collected by the Georgia Tech OSHA consultation program, even when companies implemented some form of engineering control by either using wet methods, ventilation, or both wet methods and ventilation, the exposures were still 2 times the permissible exposure limit and ranged from 9.6 to 370 micrograms per cubic meter. To prevent the development of these illnesses, employees fabricating stone that contains silica should receive hazard communication training for silica, be provided for and fitted for respiratory protection, be enrolled in a silica exposure medical surveillance program, and use tools fitted with water and ventilation to further reduce dust. Thank you for watching Lesson 5 of the Silica Exposure Training for the Cut Stone Industry, a training on the identification, evaluation, and control of silica exposure in the cut stone and stone fabrication industries. This material was produced under grant number SH37200 SH1 from the Occupational Safety and Health Administration, U.S. Department of Labor. It does not necessarily reflect the views or policies of the U.S. Department of Labor, nor does the mention of trade names, commercial products, or organizations imply endorsement by the U.S. government.